So these are the notes on angle-pair relationships. If you are in the Pinnacle class, then this is section 12.1 and 12.2. And if you're in the regular track class, this is sections 7.1 and 7.2. So I'm going to leave a space here for us to fill in the chapter and the section. We'll do that in class, but then I'm just going to write the title that it's angle-pair relationships. So that way I don't have to record this video twice. So angle-pair relationships. But again, if you are in the non-track class, you can write this. I'll show you what you would write. So if you're in the non-track class, you would write 7.1 and 7.2 angle-pair relationships. And if you're in the Pinnacle class, in your book, it's 12.1 and 12.2. So depending on which class, you'll fill that in. I'm going to leave mine blank, like I said, so that I only record this once. Okay. So let's do our cute little decoration around there to emphasize our title. Okay. So first, congruent angles are angles that have the same measure. So you should pause the video and write that down. Congruent angles are angles that have the same measure. And this symbol that we have in parentheses there is a symbol for congruent. You'll notice that it looks a lot like an equal sign with like a Spanish tilde over the top. And really, you can probably think of things that in geometry that are congruent as being like equal, but we reserve the term equal for numbers and not for shapes. So when we're trying to kind of express that same idea of equality that we talk about with numbers, we use the word congruent for figures and shapes and things like that, things that, angles, geometric figures. So we use the congruent instead of equal. We say numbers are equal and like shapes are congruent. In this case, angles are congruent. So first we're going to talk about a special pair of angles that are congruent. So we're going to draw a picture. So if you have a straight edge, that will be helpful. And we're going to draw two intersecting lines. So go ahead and draw two intersecting lines like I'm going to do right now. Now let's number our angles. So just so it makes it easier for us to refer to them. So let's call this angle 1, and this angle 2, and this angle 3, and this angle 4. And again, your angles don't have to look exactly like mine do, but just number them in kind of a consecutive order. All right. And so now let's illustrate what vertical angles are. So vertical angles are angles formed by two intersecting lines. So we have two intersecting lines here. They're lines we can tell because on each end there's little arrows to indicate they go on forever and ever. So when you have two intersecting lines, it forms four angles. And angles that are opposite each other are vertical angles. So for example, 1 and 3, we would consider those to be opposite each other. So this angle here and this angle here, angles 1 and angle 3, those would be vertical angles. So on the side, let's write angle 1 and angle 3. Those are our vertical angles. And then let's also highlight the other pair, because when you have two intersecting lines, it forms two pairs of vertical angles. So angle 2 and angle 4 in this picture, those are also vertical angles. So angle 2 and angle 4 are vertical angles. Are vertical angles. So 1 and 3 are vertical angles and 2 and 4 are vertical angles. So when you have two intersecting lines, you get two pairs of vertical angles, and those angles are kind of opposite each other. I've heard some teachers say like their noses touch. Like if you think of this as like the nose of the one angle and this is the nose of the other angle, right? So one thing that hopefully looks kind of obvious, look at those angles and think about how they appear to be related, like size-wise. If you look at 1 and 3, they're vertical and they're kind of tiny angles. If you look at 2 and 4, they're vertical and they're kind of big angles. And it turns out that angles 2 and 4 have the same measure, and angle 1 and 3 have the same measure. And we can imagine them, those intersecting lines, kind of opening and closing. So if these are our lines, kind of if you imagine moving the angles so that the top ones get bigger or the top ones get smaller, and the ones that are vertical to each other would correspondingly get bigger or smaller. So when things have the same measure, we say they're congruent. So right here we're going to write vertical angles are congruent. And what does that mean that they're congruent? Well, up top we said it means that they have the same measure. So if we've got angle 1 and angle 3, so angle 1 and angle 3 are congruent. So this is the symbol. That's how we write that. And angle 2 and angle 4 are congruent. Therefore, right, so that means that, right, so we'll write therefore, or you can write the math shorthand for therefore, which is 3 dots. So therefore, the measure of angle 1 equals the measure of angle 3. And the measure of angle 2 equals the measure of angle 4. Now, I just got finished saying before that angles aren't equal, that they're congruent. But notice that I'm not saying that the angles are equal here. I'm saying that if you measured them, that would be equal. So when you measure an angle, you get a number for the value of for the measure of that angle. So if you were to measure the angles, then the angles, their measurements would be the same number. So those measurements would be equal. Okay. So that was vertical angles. So then there's other angles that we're talking about here. And another type of angle pair we're going to talk about are adjacent angles. So let's define adjacent angles. So adjacent angles share a common side and have the same vertex, but don't share any interior points. So let's draw a picture, and that should help us understand a little better what adjacent angles are. So underneath here, let's draw kind of a larger angle, like something that's maybe 110-ish degrees. So let's draw kind of a bigger angle. I'm going to draw this kind of to the left so that I can put some notes here to the right. And then let's draw another ray here inside this angle. And let's put some points on our angles so that we can name the angles. So let's go with A, B, and C here, and we'll call this D. So let's first look at these two angles. So angle ADB, so this angle here, ADB, so the vertex is the angle you say, the letter you say in the middle. So angle ADB and angle BDC, so BDC, that would be this angle here, those two angles are adjacent. And I messed up there, I meant for that to be pink, but that's okay. Are adjacent. So this definition might seem overly wordy, but really to be technically correct, you really need all of that. They share a common side, so let's see how they fit that definition. They share a common side. So if we were to trace angle ABD, we would trace it like this, right? We're kind of tracing over the sides of ABD. And then if we were to trace angle BDC, we would trace it like this, right? And in tracing those angles, you'll notice that this side was in both of the angles. So there's the common side. The vertex for both is D, but they don't share any common interior points. So if I was to shade the rest of this angle in pink and the rest of the interior of this angle in yellow, there wouldn't be any overlap of the yellow and pink. But if we look at two other angles that we've drawn here, like for example, angle ADB again, so angle 80, so let's write but, because we're going to show an example of angles that are not. But angle ADB and angle ADC, so ADC would be this big angle here, those are not adjacent. And let's look at why. They fit some of the criteria, but not all of it. So ADB, this one up here, like the yellow one, and the big one, they do share a common side. They share this side. Look, this is a side in the yellow one, and this is a side in like that purple one. They have the same vertex. They both have D as a vertex, but they do share interior points. So if I were to shade all the purple area in and all the yellow area in, they would overlap. So those would not be adjacent angles. So they fit some of the criteria, but not all, so those are not adjacent. And then the last type, special type of angles are linear pairs. And they are adjacent angles formed by intersecting lines. So they're adjacent and they're formed by intersecting lines. So if we draw a pair of intersecting lines, so I'm going to kind of only draw half of the one line. So I would draw it kind of going all the way through, but just to help emphasize what they are, I'm just going to draw the rest of this line dotted, so as not to take away from kind of the important part here. So if we focus, say, on this angle here, and this angle here, those are linear pairs. That's a picture of a linear pair. There's other linear pairs here. These two angles would be linear pairs. These two would make a linear pair. And these two would make a linear pair. Right? And linear pairs, because they together make a straight angle, they're supplementary. And that means that the sum of their angle measures is 180 degrees. And those are our three special angle pair relationships: vertical angles, adjacent angles, and linear pairs.